And in this tutorial, we are going to make it to the next level. So let's see how it looks. So here we have me, and you can see we are doing the object recognition here using, I have two papers in my fingers and it is detecting those objects, and you can see the pointer is moving according to this point in the center, which is connecting line of which this line is connecting these two objects from the center, and this is the center of that line. So what we can do is we can grab this object, we can move it somewhere, we can put it here, let's say. We can grab this, we can put it somewhere here, we can grab this one, we can put it somewhere here, and uh, we can do dragging, select multiple objects, put it somewhere, let's say here. So this is a cool way of doing gesture recognition using color segmentation. So let's start. For this, you need two external libraries. One is called mm, me- one is called pynput. Okay, let me type it. If you are using Ubuntu or Linux or Mac, you have to use sudo. Otherwise, Windows user doesn't need this sudo. And you can use pip install py input and with my password. And you can see I have already installed it, so it's showing that already satisfied. And for this, you might also need this Python object core and Python C. You can do that by, okay, so you can do that by pyobjc-core. You can install that, and you can install pyobjc. So after installing those two, you can install py input. So after you have got py input, you need another library called wx python. So install that. So you can see I have already installed it, and now we can close the terminal. Let me open a new file here and close this one. What we are going to now here what we are going to do is, this will be the base of our program. Now what we need to do, we need to import the libraries that we just downloaded and initialize some objects, like we need from py input dot mouse import button and controller. Button will select the which mouse button, left or right or middle, we want to click, and controller will be doing the main mouse movement and mouse operations. Mm, After that, we need to create a mouse object using the controller. Let's copy this controller, and mouse equals controller, and this will be our mouse object. And we need to create, we need to get the screen size of our monitor. So to get that, we need to use another library called wx, and to use wx we need to create an app. we're not going to use it anywhere, so we are just initializing it to use the wx functionalities dot app, and this will be false. And now we can use the wx dot get display size to get the screen size. We are using it in a variable sx comma sy, which defines the screen width, screen x coordinate, screen y coordinate. This is the maximum size of the x and y, equals wx dot get display. This will get display size. It will give us the coordinate, the size of our um, monitor. Now what we want, we are going to define the camera capture resolution, which cam x comma cam y. The camera will capture the image in this resolution, so we are going to define it manually, which will be 320 comma 240. This is just going to make the capture operation faster and smoother, so we don't need to resize it to lower the size. So we are commenting this, and by any chance if uh, the image, your image is not capturing, is not getting captured in this resolution, you can again uncomment this, so this will make the process faster. To set the resolution, we need cam dot set as, for width we need 3 cam x, and for height we need 4. By the way, these are the only flags, nothing fancy. So now the camera will capture the image in this format, in this size. Okay, we don't want fonts. Let's get rid of it. And we don't want this for loop also. And we don't want this for loop because we are not drawing the objects. So we are done with the initialization. Now what we are going to do is we are going to detect if it's an open gesture or it's a closed gesture. Now to do that, we are going to use two simple logic. That is, if there are two objects, means two contours, and we also don't need this one. Okay, so if there are two contours, that means there are two objects, means it's an open position, and if it's a one, that means it's a closed position in closed gesture. So if length of the contour cons equals 2, then we are going to do is we are going to detect the two contours, boundary of the two contours, which will be x1 y1 comma w1 comma h1 equals cv2 dot bounding rect, and we need to give the cons of the first contour. This will give the boundary rectangle of the first contour, and we need the second one, and I'm going to name it 2 2 2 2, and here it will be 1. Oops. Yeah, so let's draw this bounding box just to make it fancy. cv2 dot rectangle, and we need to give the source image comma the initial coordinate. Oops, it's caps lock. x1 y1, and the final coordinate, which will be x1 plus w1 comma y1 plus h1, and we need the color, which will be I'll be using blue for this, and the thickness is 2. Same goes for the second one. Oops, let's copy this. Okay, copy, paste. So this is the second one. I just have to make it 2. So it will be 2, it will be 2, this one will be 2, this one will be 2. Okay, and let's run this and see if it is working. And I'm not using these masks because we don't need it anymore. These were just for the debugging. You can comment it, and let's make it 5 instead of let's run this. Okay, let me wear this papers in my finger again. Something is wrong. IMG, is that a capital I used? Where it is? Okay, it's because of the caps lock. Let's run this again. Let's see. Okay, so this one is detecting the squares, the objects pretty well. What we need to do is we need to point a line from this center of this object to center of this object, which will be from somewhere from here, somewhere from here to somewhere here. Okay, so to do that we need to find the center of each object. That's pretty easy actually. So I'm going to, for the first one, I'm going to use c1x for the width, center width, which will be x1 plus w1 by 2, and cy1, which will be y1 plus h1 by 2, and same goes for the second, which will be cx2 equals x2 plus w2 by 2, and cy2 equals y2 plus w2 by 2, and we have the center of both object. We need to create a line, cv2 dot line, the image. If we press the if we type the first bracket, we can see what are the parameters. So we need the image, source image, we need the first point. With the second point we need to give the color and thickness. That is pretty much the same for the all of these drawing operations, drawing functions. So we can copy, let's not copy, image comma point 1 is cx1 comma cy1 comma, the second one is cx2 comma cy2. Now the color, let's make it blue, and the thickness is 2. You can make the thickness in whatever you want. So let's test this. Let me put the papers again in my finger. You can see it's drawing from the center of this object to center of this object. Now what we want is center of this line. So this is what our reference of our mouse position. So whatever the position of this center of this line, it will reflect on our pointer. So let's try this. Let's close this. To find the center of the line, we just need to find the center of cx1 and cx2 and cy1 and cy2. This will be easy, and I'm going to call it cx equals cx1 plus cx2, enter, coordinate divided by the entire thing divided by 2, and cy equals c, let's put a bracket first, cy1 plus cy2, entire thing by 2. So we have our center position of the line, and we can put a circle there. Actually we want a dot there, but let's use the circle, the same thing, but let's see what are the images, what are the parameters. Image comma, the center will be c, why it goes away, okay, cx comma cy. Now we need the radius, which will be 2, so that it becomes a dot, and the color, I want this one to be red, and the thickness, which will be, let's make it 2. So let's try this again. I need to put the strips in my finger. Okay, so we can see that it's pointing, you can see the center of the object. Point of this is, even if we move our fingers too much, the center point doesn't move very uh, abruptly. So if I am trying to grab an object, so, and I'm pinching, so the move, while I am pinching, the mouse pointer doesn't move away from the object. So that goes the drawing part. Now we need the mouse operation. So before doing that, let's do the pinching gesture, the close gesture. Close, lf len cons equal 1. If there is only one object, that means it's close. Let's close this first. It's annoying. Okay, so what I need, I will copy this one, copy it, paste it, and as it's only one object, I can get rid of these numbers. So after deleting the bounding box, let's draw the bounding box, rectangle, and the image same goes. Let's just copy. Okay, it's fine. X comma y comma x plus width comma y plus height, and 255 0 0 2. So this will draw the bounding box. And another thing that I want is, I want to put a circle around the bounding box, so that will indicate that I'm holding the object. So for that I need to find the center of the bounding box. That will be cx is equal to x plus w by 2, cy equals to y plus height by 2, and to put the circle, cv2 dot cir cle circle, and the image, the center of the circle, cx comma cy, the radius of the circle, that will be width plus height divided by 4. This will make a radius of the bounding of the circle, which will just grab the bounding box. So after the circle, we need the color, which I want it to be red, and the thickness is 2. So that is it for all the decorations. Now what we need, only the mouse moving part. So let's, before doing that, let's test this one. So this is the open gesture, this is the close gesture, open gesture, close gesture, and open gesture. So let's try to move the mouse. Let's close this first. Okay, to move the mouse, what we need to do is, we just need to use mouse dot position and the position of the cursor. Now these C1 and C2 is the position referenced from the image window, which is very small one. We want that coordinate to be transferred to the screen size. So the image resolution is this, the screen resolution is this one that we captured from this. So we have to convert this coordinate from this coordinate to this coordinate. So that will be easy. What we just need to do is we need to make a cx multiply sx by canx. This will convert the x coordinate from camera to screen. And for y we need cuy multiply with sy divided by camy. Okay, so we have a position converted to the screen coordinates. While we just copy this, okay, mouse position, it's not a function, mouse position equals, so just copy this. I don't know why it is happening like this. Shift copy paste, I don't know, USC mouse position. While mouse position not equal to this, I will be just waiting. Pass. So this will wait for the mouse to be in this position. So we can use the same thing. I don't know why. Copy it. Control C. Press it here. And let's try this. Okay, so this thing and this thing. So yeah, my mouse is moving according to the center position of this, and one thing to notice is, although you can see that if I'm moving my hand at the left direction, the mouse is moving in the left direction, but actually what is happening here is I'm moving my mouse in the from my perspective, I'm moving my mouse at right, but the pointer is moving at the left. So to fix that, we need to invert the X position of the mouse. Let's close this first. To do that, what we need to do is we need to just reverse the values. Just make it sx minus this one. So that will fix it, and we have to make it here also in both position, otherwise it will stuck in an infinite loop. Sx minus, and same goes here, sx minus and sx minus. So that's it. So now it will fix that issue. So now what we have to do is, whenever we are closing our fingers, means it's a close gesture, we just have to click the mouse. So it will be mouse dot press. Now the button that we want to press, button dot left, and this will do the trick for the dragging. And whenever our we are opening our fingers, it will do a open release operation. So this will put okay, let's make it in the beginning, mouse dot release, release, release. So let's save it and run it and see if it is working as expected. Although there are few things that we need to do, that is making the mouse movement more smoother. And so this is, let's drag it, it is dragging. but you can see the mouse movement is not that much smooth. And another thing is, it's continuously clicking the object. Okay, I don't know what happened there. Hey, I don't know what happened there. Okay, so this is what till now we have done. In the next tutorial, we will be making the mouse movement more smoother so that it doesn't shake. It's the mouse, even if you are placing your finger in a same position, mouse is still shaking, and whenever you are moving the mouse, it's the movements is a little bit shaky. Another issue is, if we have one single object, we're still clicking it here, and uh, if you see, it's not dragging the object. You can see it's continuously clicking. Let's start by fixing the movement issue. What we are going to do, we are going to create a dampening method. uh, what it will do, it will not allow the mouse to move very fast or rapidly. It will dampen the movement, so it will move more smoother. So for that we need uh, the previous mouse coordinate. That is, let's call it m location old, and for the first time let's make it 0 comma 0. And what we are going to do, we need another mouse coordinate, which is the mouse coordinate after applying the dampening. So that we will call mouse look. So that will be, let's call that, let's initialize that with 0 comma 0. So basically the mouse dampening method will be like this: mouse look equals whatever the current mouse movement, mouse location that is detected by the camera, current target, we can call it target location, minus, sorry, it will be mouse old location plus target location minus mouse old location and damping factor. So this will decide how much smoother the mouse movement will be. So if we make this very less, means if the value goes, or we can make it, um, this should be actually, make it by dampening factor. This one makes sense more now. So the more this value, the smoother the mouse movement will become. Let's say we make it 0.1. The mouse movement will be very smoother, but it will be very slower. We don't want that, because we want our mouse to be move as fast as our hand moves, but we also want the movement to be smoother. So we want this constant to be well balanced, so that we can find out by experimenting with this value. So let's create a variable for this, equals, let's, for the sake of this tutorial, let's make it 0.5. And another thing is, the value of this constant should lie between 1 and 0, should be between 1 and 0. So let's implement this. So here we are setting the mouse position. Instead of giving the actual mouse position, we will give the damped mouse position, which will be, we can copy this. Let's copy it. Sorry about one thing, that this value has to be more than 1. So whatever value we give, we have to make it a damping function, we have to make it more than 1. So let's make it 2. Now now it's fine. Okay, so we can copy this method from here and paste it. So this will be our uh,
It's 9
pre-processed,
o'clock.
or this will be our processed version of mouse coordinate, and this is our target coordinate. So we can use this difference between the previous position and the current position, the target position, and and divide that by the damping factor. That will give us the um, processed mouse coordinate that we want. Let's put this in our. Okay, so here we have to, instead of cx, we have to place mouse location of 0, and here instead of cy we have to put mouse location of 1, and here also just we can just paste this here. Okay, that will do. So we have applied our function for the open gesture. One thing left is we have to do at the end of this, we have to store the current whatever the mouse position we got, we have to set that as our current old mouse position, which will be the m old m location of mouse location of old equals the current whatever the mouse location we processed. So this will set the current location as the old location for the next iteration. Same goes for this one. We just have to copy this and paste this. Nothing fancy. Okay, so I can just move this to. So that's it. This will make the mouse movement smoother. So let's check if it is the damping factor is good or not. Let's run this. Okay, something is wrong. Unsupported operation between tuple and list. Okay, so to make this function work, uh, we have to make these coordinate as, because these are right now lists. We cannot subtract values from list or multiply values to list. So for that we need, uh, instead of list we can use numpy array. So here we can use np.a array, and this will create an array which we can use for mathematical operation. Array. So now we can use this. Let's try with. Okay, now we can see that the movements are much smoother and it is staying in a particular location. So all we are left now is the clicking issue. So let's fix that. Okay, so let's first close this one. What we are doing here is, whenever there is a single object that is detecting, we are taking that as a click operation, and we are using this mouse dot press. But when we are dragging, the camera is still detecting one single object, and it is going inside this loop and keep pressing, keep sending this mouse press command. So we need a flag to tell the program that this mouse press is already there, we don't have to press it again. So for that, let's create one flag. uh, Pinch flag equal 0. This will tell the program that we are already in a pinch gesture or we are in an open gesture. So what we will do here is, in the open gesture, if the pinch flag equals 1, then only we will release, otherwise we won't be releasing the mouse again and again. And we will be setting the pinch flag equals 0. So 0 means it's not a pinch operation, and 1 means it's a pinch operation. So if we are in an open gesture, we will be checking if the pinch flag is 1. If it is 1, then we have to make it 0, because we have opened our fingers. So we are making it 1, and we are also releasing the mouse. The same goes for the close gesture. We just copy this and we can paste it here, and we can we will be checking for 0. If it's a 0, then we will be setting it as 1, and we will be clicking the mouse. So this will be our operation, mouse operation. So now it will only click if it will only click once, not twice. So let's check this. Let's run it. Okay, so let's try to click, and perfect. Now it is okay. Now it is able to drag. Okay, now it's perfect. So one another thing that is left is, uh, if there is one single object, still it is clicking. So what if, let me just minimize this and minimize this. So what if my I am sliding my finger and suddenly one of my finger goes out of the screen? It will start clicking. So we don't want that, because we were moving our hand out of the screen and it started clicking. So to fix that, what we need to do is, let me open that window again. We will be checking if this if it's a sudden click, means the two objects suddenly becomes one, then we will filter that. And if it's like these two objects are slowly coming together and forming a single object, then we will allow that to become a click. So how can we do that? uh, we will simply measure the total width of total area of the two object, and after becoming one object, the total area of that object. If those two are almost similar, almost the same size, not very the gap between those two area is not very large, then we will take that as a click. Otherwise, like, this two object will now cover a large area, if we combine them, if we combine both of them. And if we suddenly close this, remove this object, the area of this will become very less. So there is a large difference between these, the open and the close, I mean the close and the open. So we can filter that easily. So let's do that. In this pinch 0, we will be using another if condition. That is, okay, first we have to check the xy coordinate of the detected object. Now, so before that, what we need to do, we need to somehow capture the previous locations of the two objects when we had an open gesture. So we can capture it in this block. Let's name it openx comma openY and open width comma open height equals, and this one will be the bounding box containing both of the objects. So it will be cv2.bounding-box, and this bounding box will contain all of these coordinates. So it will be x1 comma, so it's not a contour, so it will be np dot array, and in this array what we have to do first, we have to create a list of list, and that inside that list of list we have to put the coordinates. That will be x1 comma y1 for the first coordinate, comma for the second coordinate it will be x1 comma x1 plus w1 comma y1 plus h1. So we are done with this two, we have to now add these two, comma x2 comma y2, and we have to give the last one, that will be x2 plus w2 comma y2 plus h2. So that's it. It will create a bounding box which will cover the both objects. So let's see how it looks. So we can see that if we put a rectangle, come on, if we put a rectangle here, we will be able to see. So here this one will be open x, this one will be open y, this one will be open x plus open w, this one will be open y by open h. So this is just to show how that bounding box will look like, though it's an optional. Something went wrong. Okay, so here I missed another I missed an parenthesis. Okay, now it's fine. Let me um, okay, now it's fine. Another invalid syntax. Okay, we will be dealing with this later. Okay, so here you can see the outer bounding box is now the thing that we calculated here. This openx, this openx and openY, openw and open edge, this one is creating the outer bounding box. So we will be calculating the area of this one, and we will be comparing with the area of the combined object. So if these two are very much similar in position and shape, then we will be considering it as click, otherwise we will be ignoring it. So let's do this. Okay, so we have this open x, this total combining rectangle. So we have this values, we don't need this anymore, uh, we don't need this rectangle anymore. So it's just to show you. So now what I'm going to do is we will be checking the area, which will be w multiplied with h. Okay, so the area minus the previous area, which will be this one, multiplied by wh, and this should be the difference between these two should be very minimal. Let's divide this with the old area. So this is the percentage of error or the difference. If we multiply this with 100, then we will get the percentage of difference. So this is the percentage of difference, and this can be positive or negative. So we have to use something called absolute. So we will be using the absolute of this abs. So absolute of the entire value. Okay, so absolute of this should be less than, let's say, 20%. So if the error difference is less than 20%, then we will take that as click, otherwise we won't be taking that as click. So let's run this. Invalid syntax, where? Okay, so let's we haven't finished it yet, so we have to put it inside. And another thing, once we have verified that it is not inside that, it's not complying with this rule, then we know that it's not a click. So we will be making this as 0, 0 comma 0 comma 0 comma 0, so that this situation, this condition never satisfy even after the next iteration, because it's already verified that it's not in click. It's already verified that it's not a click, so it will not retry to fix that, retry to find if it's a click or not. So let's run this. OpenW. Okay, so it is not these values are, we have to make it global, otherwise it will not able to detect these. Okay, another thing we can do is we can make them here. We can press them here. Let's run this. I hope it runs. Okay, something is wrong. Okay, so one thing is that we cannot, it's a divided by 0, so we cannot divide it by this, because it's a 0. So what we can do is we can use w and h, so it will make it simpler. Okay, now what is happening, it is still it's not clicking, as you can see. Let me just move it to this side, move it to this side. So it is clicking, it's dragging, but and if we do like this, it is not clicking. So even again, if we do it like this, it's clicking, so it's fine. But one thing still is bothering me is that if it is not a click, why should we display this or move this mouse? we shouldn't move this mouse, because we are supposed to move the mouse if it's the gesture is like this. So to fix that, what we can do is, hmm, let's close this. We can put the entire thing in else part. So their drawing rectangle and the calculation, everything will be in the else position if it is not a click. So if we put this entire thing in else part, then it will only move the mouse if it is a click, and if it will only be a click if the absolute difference between the old area and open gesture area and the click area is less than 20%. Oh, what happened? Oops. Okay. While I just have to move this one also. I think it's fine. Okay. Yeah. Let's run this, and let's put this in my finger again. Now if I suddenly hide my this finger, it will not act as a mouse, and if I do it like this, then only it will click. So it's fine, and the movement is also smoother than the previous program, and it's able to drag. And okay, so uh, let's make this value 30%. Okay. Okay, let's just see. Let's minimize this again, minimize this again. Okay, so it's fine. Okay, so that's it. I hope you enjoyed this tutorial, and it helped you a lot. And if you did, please give a thumbs up and smash that subscribe button. And I'll be seeing you in the next tutorial. Okay, I did that. Okay, great.